In this video, we're going to make sure that the power dissipated by a certain resistance is going to be null. So let's see how to do that. Well, it's actually pretty straightforward. It's actually pretty easy. So let's draw our circuit as always, as we always do. So our circle this time is going to be easy, fairly easy. So nothing like the, the former one, but still. Anyway, so this is going to be my voltage generator, V1. And then I'm going to have a resistance here. Then I'm going to have a node. There is another resistance here. Then I'm going to have a current generator called J. And then down here, those two are connected. And we will then have another third resistance here. So I'm going to call this one R1, this one R2, and this one R3. Yeah. So the problem this time is saying, as I anticipated, so for the circuit, yeah, I'm going to write it each time, but I'm getting tired of writing it down. But anyway, for the circuit below, we know that Ri equal I ohm. So basically R1 is going to be 1 ohm, R2 is going to be 3 ohm, R3 is going to be, so R1 is going to be 1 ohm, R2 is going to be 2 ohm, R3 is going to be 3 ohm. J is equal to 2 amps. Find the value of V1 so that the power dissipated by the resistance R3 is null. Okay, so what do we have to do here? Well, we're gonna find the value of V1, which we don't know, but we gotta make sure that the value of V1 is at such a certain value such that the power dissipated by this resistance here is null, so it's basically zero. So how do we do that? Well, first thing first, it's basically asking us to make sure that the power dissipated by this resistance here is null. So what's the power dissipated by this resistance? Well, the power dissipated by the resistance R3 will actually be, and I'm going to call this PR3. So the power dissipated by R3 will actually be R3 times I3 squared. So if we want this to be 0, it basically means that I3 must be 0. So in order for it to be 0, so basically I mean PR3 to be 0, I3 must be 0. Okay, makes sense, right? Because, you know, PR3 is given by a resistance, which is a certain value, is 3 ohm times I3 squared, but I3 squared must be 0 because one of those two gotta be 0. This one cannot be 0 because it's finite. It's a 3 ohm, so this one must be 0. So, by the way, let me just say, yeah, 1 ohm, 2 ohms, and 3 ohms, okay? Oh, and this one is 2 amps. So this one must be 0. So let me just rewrite this. Well, no, I'm not going to rewrite. Let me just say and call these plus minus VR3. Okay, let me just call this VR3. So I3 must be 0, but what is I3? How can we find I3? We know that it must be 0, but what is I3? Well, I3, which we know must be 0, but I3 is given by VR3 over R3. Okay, this one I just defined the basically this one between those two ends. Okay, so VR3 over the resistance. So the current is given by the voltage over the resistance. Pretty simple, is Ohm's law. But then again, we know that I3 must be 0. Therefore, R3 is finite, so VR3 must be 0. So we know that I3 must be 0. So again, VR3 must be 0. Makes sense, right? This one is finite. This one must be 0. So 0 over a number which is finite is still 0. So this one must be 0. Now, taking this into account, I can actually apply Kirchhoff voltage law to this end, okay, to this closed loop on the left hand side. So I'm basically gonna consider this mesh, this closed loop on the left hand side. So taking this into account, I'm gonna apply Kirchhoff voltage law to the mesh on the left. So it basically means this one on the left. So if I'm going to do that, taking this into account, as I said, I'm going to have that V1 minus R1 times J is going to be equal to, well, to what? To VR3, which is going to be equal to 0. So now I can actually say, okay, fair enough. I can find V1, which is the one that is asking, this is basically asking us to find, because V1 is actually going to be R1 times J. So V1 is actually, if I just substitute those two guys, it's going to be R1, which is 1 ohm, so 1, times J, which is 2 amps, so times 2. So 1 times 2, V1 is just 2 volt. Just like this, as simple as this.